deal with the introduction to integration. So integration is the process of finding the antiderivative. So let's say we have d dx of the function of x cubed. So now the derivative of x cubed is 3x squared. And when you integrate this function, it's 3x squared dx. So applying the power rule in integration, you have that this one is 3x exponent 2 plus 1 divided by 3 plus c. So you'll get that this one and this one will cancel each other. So you'll have x cubed plus c. So since this one is the derivative, this one it is the antiderivative. And that is integration. So now, let's deal with some examples. Or let me give you some notes so that you can copy them. Because these are just formulas that you will need in future so that you can deal with integration. So I will start with this one. Let's say you have the integral of x to the n dx. So the integral of x to the n dx is equals to x n plus 1 divided by n plus 1 plus c. And this rule only works when n is not equals to -1. I believe you are copying these notes. Another one is k dx, where k is a constant this time. So this one is equals to kx plus c. Another one is the integral of 1 over x dx. So the integral of 1 over x is equals to the ln, the absolute value of x plus c. And the fourth one is the integral of a to the ax dx. So you need to, let me just remind you something. Remember, when you derivate the exponent d dx of ax, you write ax times the derivative of the exponent ax. So since you multiply in derivative, in integration you are going to divide. So you'll have a to the ax divided by d dx of the exponent plus c. So this time, let's say I given the integral of two functions, f of x dx, plus or minus g of x bracketed by dx. So when you use sum rule here, you will have that this is equal to the integral of f of x dx plus or minus the integral of g of x dx. Another one is if you have a constant and a function, you are allowed to take the constant outside the integral sign. So you can have k, the integral of f of x dx plus c, which is the constant of integration. Now, let's deal with the integration of trigonometry. So remember, the derivative of sine x is equals to cosine of x. So how about the integral of cosine of x? It will be equals to sine x plus c. So I'm no longer going to put x alone here. I'm going to put ax to be our angle. So the derivative of cosine of ax is equals to minus sine of ax times the derivative of ax. So since in derivative you multiply by the derivative of the angle, in integration you are going to divide by the derivative of the angle. So the integral of sine ax dx is equals to minus cosine of ax divided by d dx of ax plus the constant of integration. Now I believe you get the idea. So the integral of tan x, the derivative of tan x is sec squared x. And the integral of sec squared x dx is equals to tan of x plus c. And let's go to this one. D dx of sec of x is equals to sec x times tan x. So the integral of sec x times tan x dx is equals to sec x plus c. And since the derivative of cosec of x is equals to minus cosec of x times cot of x, then the integral of cosec of x times cotangent of x then is equals to minus cosec of x plus c. The last one is, since the derivative of cot of x is equals to minus cosec squared x, then the integral of cosec squared x dx, then is equals to minus cot of x plus c. So the information that was provided in this video, it is there to help you to utilize it in the next videos when we'll be dealing with problems that are involved in integration. So it's very important to know the integral of sine, the integral of 1 over x, the integral of anything that I gave you. It's very important. So if you have not yet subscribed to the channel, subscribe for more updates. And thank you very much for watching.